Assalamu alaikum dear student. My name is Dr. Muhammad Adnan Asghar, and today the topic of our discussion is how to find symmetry elements and operation in different molecules under the subject of symmetry and magnetochemistry. This lecture is actually the continuation of the last lectures where we also study the how to find the different symmetry operations in different molecules. So here is another example. Find out the complete set of symmetry elements in BRF3. So here is the molecule BRF3. We need to find all kind of symmetry elements and symmetry operations if present in this BRF5 molecule. So first of all, we know that we should write the identity first, E. So after writing identity, we should have to find the different type of proper rotations if present. So from here we can see that if this would be the axis of rotation for BRF5, then there is C4 rotation. So if this is the axis of rotation, you can easily understand this is actually the C4 rotation axis. So you can rotate this molecule in C4 fashion. Is there any kind of axis of rotation present? So after finding C4 axis of rotation, is there any other axis of rotations found in the square planar pyramidal BRF3? Yes, there is a C2 also in square planar pyramidal BRF3, and I will show which would be the axis of rotation for C2 rotation. So after this, is there any plane of symmetry is present in this molecule? Is there any inversion center and any improper rotation is found? So first of all, I would like to share about the inversion center. Did you find any kind of inversion center in this BRF5 molecule? Think about this. No, there is no inversion center in this BRF5 molecule, but there are many sigmas plane of symmetry present in BRF5. Here you can see that there are almost 4 plane of symmetries present in this molecules. So first is this one, sigma V, and the same is with sigma V dash, or you can say sigma V, both these are types. So the other two are the sigma D. So there are 8 symmetry operations found in this molecule: identity, C4, C2 and C4 thrice, 2 sigma V and 2 sigma D. I would like to show the 3-dimensional structure of this square planar pyramidal geometry so that the things may come more obvious and clear in the mind of you people. Here is the 3-dimensional structure of BRF5. We know that bromine have 7 electrons in their outermost shell, so it forms a 5 different types, 5 covalent bonds with the adjacent fluorine. So 2 electrons in the form of electron pairs, lone pairs available. So if we see the 3-dimensional structure of BRF5, we can easily understand there is a C4 axis of rotation. If we rotate this molecule clockwise or anti-clockwise, for example, I would like to rotate this clockwise, this one of the fluorine shift its position over there, and this one subsequently over there, and all the molecule shift their positions according to their rotations. So this is the axis of rotation for C4 molecule. This is the axis of rotation for C2 as well, and this is also the axis of rotation for C4 thrice. So this is all about the axis of rotation in square pyramidal geometry. There are different sigma V. We can say this, there are different sigma V's present in this molecule. There are 4, 2 sigma V and 2 sigma D. This is the complete illustration of symmetry elements and operations present in this molecule. So the next is XeOF4, which is the xenon oxide tetrafluoride. So try to find the complete set of symmetry elements and operations in this molecule. Yes, there is identity first. We need to write identity first. So next is the proper rotation. We need to find the proper rotation very carefully. You can easily find this C4 rotation over there if this is the axis of rotation. Oxygen, if we pick this molecule from this axis of rotation, you can see there is exactly C4 rotation present in this molecule. This is also the axis of rotation for C2 proper rotation. You can rotate, you can give this you can find the indistinguishable shape of XeOF4 while performing the C2 axis from this axis of rotation. So far we have found identity C4 and C2, while both are the axis of rotation is the same. The third is the C4 thrice. If we perform C4 3 times, then we also get the indistinguishable shape of xenon oxide tetrafluoride. So this is also included in the symmetry operation of this molecule. So is there inversion center? No, there is no inversion center, because we know that if we move from a middle of the molecule to one specific direction, for example this direction, we find the oxygen over there, while on the other hand we need to go same distance on the exactly opposite direction. We did not find the oxygen over there, so there is no inversion center. Although this is the case with the different fluorine, we can find the fluorine in opposite direction, but in case of oxygen we are unable to find the oxygen on the other direction. So there is no inversion center in xenon oxide tetrafluoride. But there are plane of symmetries present. There are 4 plane of symmetries present in this molecule. You can see over there. This is actually the same symmetry elements and operation that we studied in BRF5. Both molecules exhibits square planar pyramidal geometry and shows the same symmetry elements and operations. Both have 8 set of symmetry operations, including identity C4, C2, C4 thrice, 2 sigma V and 2 sigma D. So the next is the diborane B2H6. Try to find the complete set of symmetry operations in B2H6, which is diborane. So we need to write the identity first. After writing identity, is there any axis of rotation or proper rotation present in diborane? Yes, there is. There is a C2 in this direction. This is actually axis of rotation of this molecule. You can see over there. Actually, we know that this type of bonds is actually the exhibiting the position of the atoms in space. This hydrogen is towards you, exhibited by solid lines, while the dotted line exhibit the away from the observer. So there is a C2 rotation from this. If you pick this molecule and rotate clockwise or anti-clockwise, you will find an indistinguishable shape, and this is the C2 axis of rotation for diborane. There is an other C2 present, which is this is the axis of rotation. If you rotate this molecule from this axis of rotation, this is the axis of rotation, you will definitely find an other indistinguishable shape of diborane, which include its symmetry operation. So first one is this one. If we pick this molecule from this side or this side, you will get the C2. The second one is the axis of rotation, this side. You can say this is the x-axis, this is the y-axis, and this is the z-axis towards you, towards the observer. If you pick this molecule from z-axis, there is also a C2 axis of rotation present in this diborane B2H6. So the next is inversion center. Is this molecule exhibits the inversion center property or not? You need to find this. Yes, there is inversion center in diborane. You can say that this is actually the middle of this molecule, middle point of this molecule, and you need to draw a line towards any direction that you find a molecule. Like here you can find a hydrogen, while subsequently on the other side of opposite direction you need to find a same molecule. So there is inversion center in all aspects you can study. If you move this, there is a boron, and same there is another boron on the opposite side. So if you like to move upward, there is a hydrogen, and downward opposite direction there is again a hydrogen. So there is inversion center in this diborane. So the next is the plane of symmetry. Yes, there is plane of symmetry is also present in this molecule. There are three types of C2 rotations we found already in this diborane. We know that there may be, you can call this is the x-axis, this is the y-axis, and z-axis towards the observer, towards you. So all the x, y, and z-axis exhibits C2 rotation. Same is the case with the plane of symmetry. There are three sigmas present in this diborane, and the axis of plane of symmetry is similar with the proper axis of rotation. So there are three sigma present in diborane, and I would like to show the three-dimensional diagram of this diborane. So you better to go to the Google, and you need to write the complete set of symmetry elements of, for example, we need to find about diborane. Yes, here you go. This is actually the chemtube3d.com. I have already discussed with you people. This website is quite helpful to understand the complete set of symmetry elements and operations. And here we go. Actually this is somehow run by the University of Liverpool students, and they continuously uploading the different structures of molecules. It will be quite helpful for us to understand the all set of symmetry elements. So first is the C2 rotation. You can see there are three types of C2s present in this diborane. The first axis of rotation is this one. If you just pick this molecule up from this upward position and rotate this molecule in clockwise or anti-clockwise, you will definitely find an indistinguishable shape, which is the symmetry element. So the next is the, for example, we can say this is the y-axis. So if you pick this molecule from y-axis and you can rotate as clockwise or anti-clockwise, you will definitely find an indistinguishable shape, and that is the C2, another C2. So the third one is the along the z-axis towards you. If you draw a line towards you and you will try to pick this molecule from z-axis, then rotate from z-axis to clockwise or anti-clockwise, there will be an indistinguishable shape of diborane, and this is also the proper axis of rotation in z-axis. So there are three C2 rotations you can see over there, and the same is the case with the sigma plane of symmetries. There are three sigma plane of symmetry also present in B2H6. So there is complete set of symmetry, and there are 8 operations we have studied so far: identity, C2, and 3 C2 inversion center, and 3 sigma V. So this is all about the plane of symmetries and inversion center and proper rotation identity present in this molecule. So the next is Find out the complete set of symmetry elements in cyclohexane. There is two type of cyclohexanes which found. One is the boat form, another is the chair form. So this time we are only going to discuss about the boat form of the cyclohexane. How many symmetry elements and operations found in the cyclohexane? So there is identity first, and there is C3 axis of rotation. You can see over there, this is actually the C3 axis of rotation of in cyclohexane boat form. There are two C3. For example, if you just pick this molecule from upward and you need to give C3 rotation, you will find you can just look at the H3 in purple color. H3 in purple color, you need to rotate it clockwise. If you rotate this molecule clockwise, C3 rotation, then this molecule will be over there, and this is actually the indistinguishable shape. So there is C3, so you need to give C3 two times. This is also an indistinguishable shape. So actually C3 is the principal axis of rotation, because this is the highest n value of rotation. I said this highest n value because there is a C2 also in cyclohexane. There are 3 C2s found in the cyclohexane. So the next is the inversion center. The question is whether the inversion center found in this molecule or not. Yes, there is inversion center found in this molecule. If you clearly closely observe, this is actually the center of the cyclohexane boat form, and if we draw a line towards any direction, for example, I would like to draw a line over there, H1, I found the hydrogen H over there. Subsequently, this is the middle of the molecule, and need to draw a line of same length but in opposite direction. Yes, here you can see this is H2, so there is another hydrogen over there, and this is actually the indication of inversion center. This is the case you can study with all the hydrogen atoms and even the oxygen even the carbon atom present in cyclohexane. So far we have studied identity 2C3 and 3C2 with one inversion. So far we have studied the 7 symmetry elements, 7 symmetry operations in cyclohexane. So there is S6 also. There is 2 S6 and 3 sigma D present in this molecule. This is actually the sigma D is present, just like C2 axis of rotation present in this chair cyclohexane boat form. For the better understanding of this molecule, we better to go to the three-dimensional structure of this cyclohexane, so that all the symmetry operations may be obvious to us. So here we go in Google, and we need to write the total symmetry elements in cyclohexane here. So this is the symmetry elements present in the cyclohexane. This is actually the cyclohexane structure in boat form. Here you can see this. There is C3 rotation if we rotate this molecule from this direction, and this is the axis of rotation for C3 and C2 also. We need to observe this molecule carefully, and 3 C2 is present along with 3 sigma V on the same axis, so same plane. There is inversion center is also in this molecule. This is all about the cyclohexane chair form, the boat form, sorry. So the next one is find out the complete set of symmetry elements and operations in oxalic acid. So the next one is the oxalic acid. For oxalic acid, we know that this is the dicarboxylic acid, and the structure of this dicarboxylic acid is like this one. There are 2 carbon and 4 oxygen atom along with 2 hydrogen. COOH twice, oxalic acid. To find out the symmetry elements, we need to write the identity first in oxalic acid. Then, is there any kind of proper axis of rotation found in this molecule? Yes, you need to think about this. There is C2 axis of rotation from this axis of rotation. So here you can see, if you rotate the molecules clockwise or anti-clockwise, you will get a definitely indistinguishable shape of oxalic acid. So the next is the plane of symmetry. Is there any plane of symmetry is present in this molecule? Yes, there is a plane of symmetry just perpendicular to the axis of rotation. For example, we know that this is the actually towards observer, towards you. From this point, towards observer, if you rotate this molecule clockwise or anti-clockwise, you will get an indistinguishable shape. This is actually the C2 axis of rotation. And just perpendicular to this axis of rotation, there is sigma plane of symmetry is present. And we know that if plane of symmetry perpendicular to the axis of rotation is present, or principal axis of the rotation is present, then there should this may be called as sigma h. So there is sigma h present in this molecule. Next is the inversion center. Did you find the inversion center in the oxalic acid? If yes, then you are quite good to find all kind of symmetry elements and operation in this in molecules. If no, then you need to think about your previous knowledge. There is inversion center in this molecule. Here is the complete set of symmetry elements of oxalic acid. Next is the find out the symmetry set of symmetry elements in phosphorus oxychloride, POCl3. So this is quite interesting molecule, POCl3. It's similar to NH3, but we know that there is no oxygen over there, and the structure of POCl3 rest is same with the ammonia. So from here we can see this, if this would be the axis of rotation, then there is a C3 in this molecule. If, for example, if you rotate this molecule clockwise, this chlorine will occupy the space of this chlorine, and this chlorine obviously go to over there, and this one will join the space of this molecule. So there is C3 axis of rotation in phosphorus oxychloride, POCl3. Is there any kind of proper axis of rotation found in POCl3? No, there would be no. Only C3 is present in this molecule. Identity C3 and sigma V. There are 3 sigma V in POCl3 molecule. So if we talk about the complete set of symmetry elements and operation in phosphorus oxychloride, POCl3, then there are 5 set of symmetry operations. Number 1 is identity, number 2 is C3, and 3 sigma V. So there are 5 symmetry operations found in POCl3. So the next example is transplatin. This is the molecule named transplatin. Actually, the platinum is attached with 2 NH3 and 2 chlorine. This is, if they are present on the trans position, then we can say this is the transplatin. And if they are cis to each other, then this would be the cisplatin. And cisplatin is quite famous about its anti-cancerous abilities and anti-cancerous properties. So what about the transplatin? There is identity in transplatin. Yes, there is C2. we need to find that this is actually the axis of rotation. If you just draw a line towards observer from platinum and you rotate the molecule clockwise or anti-clockwise, there would be a indistinguishable shape of this transplatin. So C2 is present from this axis of rotation. There are other C2 is also present in transplatin. This is the actually the axis of rotation of other C2 present, like C2, and this is actually C2. You can mark this as a C2 dash, and this C2 would be marked as C2 double dash. So there are three type of C2 present in transplatin. So far there are four symmetry operations found in transplatin named identity, C2, C2 dash and C2 double dash. There is sigma h, which is perpendicular to the axis of principal axis of rotation. So here is only C2, so we can call this axis as principal axis or the axis of rotation. So if a sigma or plane of symmetry present perpendicular to the axis of rotation, then that would be marked with sigma h. So there is a sigma h present in this molecule. Moreover, there are two sigma v are also present, just like C2 dash and C2 double dash in transplatin. So the final is there any inversion center found in this molecule? Yes, there is inversion center in this molecule. If we move from that particular mid of the molecule to any direction, for example in this direction, right side, there would be a chlorine, and moreover on the same side you need to travel the same distance on the opposite side. You will find the same molecule or atom over there, then there is inversion center. This is the case with the NH3 also. So in transplatin there is identity C2 here, C2 dash, C2 double dash, sigma h and 2 sigma v along with inversion center. For the better understanding of this molecule, we need to study the three-dimensional structure of transplatin. Yes, here you can see this is the molecule of transplatin. Here you can see this is the C2. If you rotate this molecule from this axis of rotation clockwise or anti-clockwise, there is a C2 and there are two other C2s present. This would be the axis of rotation for C2 dash that I mentioned in my picture, and from the chlorine axis of rotation there is C2 double dash. So what about the inversion center? Here you can see this is the actually depiction of inversion center. From here we can see in different format and from different angles to understand the concept of inversion center. So sigma v, what about the sigma v? There are 2 sigma v and 1 sigma h present in this molecule. This is actually the description of all symmetry elements found in this transplatin. There are 3 C2 found, C2, C2 dash, C2 double dash and 2 sigma v along with inversion center and 1 sigma h. So there are different types of symmetry operations found in this molecule. This is all about this, and I would like to assign some of the molecules for your practice to find out the possible symmetry elements along with their operations and send back to me through Google Classroom or in comments. For example, you need to find the complete set of symmetry elements of cyclohexane in board form. We have studied the chair form already. cisplatin, this is the transplatin we studied already, and ammonia molecule, because we studied the same type of molecule POCl3 phosphorus oxychloride already, so you need to remove this oxygen from POCl3 and you need to find the complete set of symmetry elements and operations for ammonia molecule. Moreover, you need to study the symmetry operations found in PTCl4. You need to find whether this molecule PTCl4 is tetrahedral geometry or square planar geometry, and we know that we have studied the reasons behind their geometries, how these molecules form the geometries. So this is all about the finding of different symmetry elements and operations in molecule. Thank you very much.